Hey guys, so welcome back. Today we're going to be talking about half reactions. Now, for us to be able to do half reactions, I suggest you watch is it 10? Lesson 10 and 11's video to really help you out. But half reaction is just a continuation of lesson 10 and 12. So you need lesson 10 and 11. You need to be able to do that before you do this. So let's get going. We're going to be writing half reactions. Now, half reactions will show us how many electrons are being lost or gained in a redox reaction. Half reaction, we're going to be writing one for oxidation and reduction. They simply show us the species that is reducing or oxidizing. That is it. That is what half reactions do. They only show us what is reducing and what is oxidizing, and just that element, nothing else. So it's more like the net equation. The net equation. It just shows us the simplest version of what is oxidizing and what is reducing. But before we can get started, I have a couple of steps that I like to use um, to help us on how to do half reactions. Then we'll identify a couple of half reactions, an easier way to identify it, and then we'll go on to writing half reactions. I have two problems that I want us to do. So, step one, you have to assign oxidation numbers. You need to assign oxidation numbers. Once you assign oxidation numbers, you know what is oxidizing and what is reducing. So once you assign oxidation numbers, to write the half reaction for oxidation, you're going to go from left to right. You're going to go from left to right, and you're going to write what you see on your reactant side and what you see on your product side. And then you'll add in how many electrons was involved for you to get from your reactants to your product. Now, the one hint that I had to say is that your electron should always be on the side that has the oxidation state. All right? Your electron should always be on the side that has an oxidation state. Once you do that for oxidation, you're also going to do it for reduction. Once again, tell me from left to right what you have, and then also go ahead and put your electrons, how many electrons were involved, on the side with an oxidation state. So these are the three steps. Very simple. This is always the format it should be in, or mostly when it comes to single replacement reaction. When it comes to synthesis and decomposition, it might look a little bit different. So here we go. I want us to be able to identify which is oxidizing, which is reducing. We're not going to do all of the problems. We're probably going to do about two or three. But I know some of you were saying you had a little bit of problem. So come up, draw a number line to help you. And then on your number line, because our oxidation states don't go that crazy, go up to about 4, right? On either side. So you have -1, -2, -3, +1, +2, +3, right? And on the negative side, that's your reduction side, because when we gain more electrons, we reduce. Once again, I'm going to write reduction as red. And then more when we have more positive side, that is when we oxidize, because that's when we have lost our electrons, right? So remember, reduction, we have gain electrons reduce. When you gain more electrons, you become more negative because electrons are negative. And when we have oxidation, Leo, lose electron oxidize. When we lose a negative particle, we become more positive. So we end up on the positive side. This number line should help you out a little bit. So being able to identify what the half reaction is representing, focus not on the species, but on the oxidation states from left to right. So as we're going from +2 to 0, that is our oxidation state, we're going from +2 to 0. Because we're becoming more negative, we are reducing. All right. For number 20, let's focusing on the oxidation state. So we're going from 0 to +3. So 0 to +3. Now, because we are becoming more positive, yes, we are oxidizing. And okay, let's do one last one, and then you guys could do the rest on your own. All right. For number 21, because we are oxidizing, number 21, because we have 0 to +2, 0 to +2, we are becoming more positive. We are oxidizing. Perfect. All right. So that should help you identify which one is oxidizing, which one is reducing. Go ahead and finish the other three on your own. Now, one thing I do want us to focus on is, let's look at number 19 and number 20. So if we look at those numbers right there, right? The only difference between the two, hopefully you can see the difference, right? Pause this and see if you can see the difference between number 19 and 20. So if you pause this, you've probably realized that the number of electrons, the way they got the number of electrons is based on the change within the oxidation state. So as we go from 0 to +3, we've lost 3 electrons. As we go from +2 to 0, we've gained 2 electrons. So that's where we're getting the electron values from. And then you also notice that our electrons are written on the side with the oxidation state that they correspond with, right? So Mg plus 2 is on that side with the 2 electrons, and Al plus 3 is on the side with the 3 electrons. Keep that in mind when you're writing your own your own half reactions for oxidation and reduction. So we're not going to do example number 2. So I'm going to go back over this real quickly. So let me just erase all the erasers. Erase pens. Alright, so like I said, we are not going to do example number 2. It's just going to be a little bit confusing if we do that. So let's go ahead and get started with this one. So I'm going to go ahead and do the oxidation states for this equation, assigning oxidation states. So magnesium is by itself, it has a 0. Zn is by itself, it also has a 0. Well, we know that zinc chloride and magnesium chloride, because they're in a compound, their overall oxidation state needs to equal to 0. But because they have individual oxidation states within that compound. Now, if you're a little stuck on this, please visit video lesson 10 to help you with this. But here we go. So I know that zinc has a +2 oxidation state. I checked with my reference table. So that means chlorine needs to be a -2 oxidation state to cancel that out. And then I know magnesium has a +2 oxidation state because it's also on group. It's also in group 2. If you notice, all group 2 elements have a +2 oxidation state. And then Cl will have to be -2. Now, once I figure that out, I'm going to find out which one is oxidizing and which one's reducing. Well, magnesium is going from Mg to MgO to Mg plus 2. So because it's going from 0 to +2, it is oxidizing because it is becoming more positive. Now, for zinc, as we go from Zn plus 2 to 0, we are reducing because we are becoming more negative. Now, I got MgO and Zn plus 2 all from the left side of the reaction. All on the left side. So now I'm going to do on the right side of the reaction, the product side of the reaction. Well, magnesium on the product side of the reaction has Mg plus 2. Right? And zinc on the product side is just zinc 0. Now that we have that, how many electrons were involved from us going from Mg0 to Mg plus 2? How many was lost? Well, 2 electrons were lost, and I'm going to write my electrons next to the magnesium with the oxidation state. So it's going to be 2E minus. And then zinc for us to go from zinc plus 2 to zinc 0, it also gained 2 electrons. So that means I'm going to write it on the side with the oxidation state once again. So it's going to be 2E minus. You must remember to write the minus sign. That is how I know electrons are involved in being transferred and lost or gained. Now, as you notice on both ones, anytime where there's the oxidation state that is not 0, oxidation state, that's where I put my electrons. And you can tell this is obviously flipped. Remember, in chemistry, there's no subtraction. We just flip the reaction around to show us what is happening. So let's practice too much problems. So this is a synthesis reaction, and this is a single replacement. Now, synthesis reaction and double replacement is going to look a little different. So this is why I had these two over here. So if we go ahead and do the first part, SR has an oxidation state of 0, O has an oxidation state of 0 because they are by themselves. Well, SRO have a total oxidation state of 0, but they have individual oxidation. Each element has an individual oxidation state within this. Well, O, if we look on the periodic table, has an oxidation state of -2. So that means SR has to be +2 to cancel that out. And is it? Yes, it is. All right. So now that I've figured that out, remember, go to lesson 10 if we're struggling with this. So if we go from SR, compare SR to SR, and O to O, we'll notice that SR is going from 0 to +2. So it is, yes, it is oxidizing. And that means O that goes from 0 to -2 is, yep, reducing. All right, so we know what is oxidizing, we know what is reducing. So let's go ahead and write our half reactions. Well, let's start with ox, and then I have my reducing here. All right. Now, well, for SR, we're going to write from what we see on our left to what we see on our right. So let's, for our left, we have SR and both O at 0. I'm going to write the O2 the way I see it in the problem, right? And both of them had zeros. And then when we go on to, we have our arrows, right? And then we have to see what we see on our product side, on our right side. Well, SR now has +2. And O now has -2. Now, how many electrons were involved from O to +2? Well, 2 electrons. So I'm going to write those 2 electrons in. So yeah, that was a little typo. Let me fix that right now. So, like I was saying, this O had to go ahead and lose 2 electrons. This O had to gain 2 electrons. So right on this side, and there we go. And that shows that on both sides they are equivalent. So let's go ahead and let's do this on over here. Once again, if the element is by itself, it's a 0. And then I'm going to go ahead and write the oxidation states for this. Once again, if you're struggling with this, look at video lesson 10. Oxygen has a -2 oxidation state, so that's going to be a +2. CU has to be a +2 then. Oxygen over here, once again, has a -2 oxidation state, and there's only one of it. And hydrogen, to cancel out this -2, has to be a +2. All right. So then I'm going to compare anything that went from 0. So H went from 0 to +2, and Cu went from +2 to 0. So if we go from 0 to +2, I'm becoming more positive. That's oxidation. And because I'm going from Cu +2 to 0, I am gaining electrons. So that's reduction. All right. So then, let's go ahead and write our half reactions. Now, I'm going to write what I see on my left and what I see on my right. On my oxidation for my left, I have H2O. On my right, I have Cu2 plus, arrow. On my product side, I have H2H plus 2. And over here, I have CuO. And how many electrons were involved? Well, for H, there was 2 electrons involved. I write that on the side with the oxidation state. And for O, there's 2 electrons involved. I also write that on the side with the oxidation state. And So there we go. If you have any questions, let me know, and you got this.